In this video, we are going to discuss differentiation, 2 marks, PYQs, previous year's questions. If y is equal to cosine sin x by 1 plus cos x, find dy by dx. The given question is, if y is equal to sin x by 1 plus cos x, find dy by dx. So given that y is equal to sin x by 1 plus cos x. See here, this is in the form of like u by v. See, if you differentiate the u by v, this is u by v rule with respect to x. U and v are functions in terms of x. Now, numerator and denominator here, which is equal to, so v into, that means denominator into, so derivative of numerator minus numerator, that is u into, so derivative of denominator with respect to x, whole divided by, so denominator whole square, that is v whole square. This is quotient rule. So now here we have y is equal to sin x by 1 plus cos x. Now differentiating with respect to x. On both sides. Differentiating with respect to x on both sides. So now d by dx of y is equal to, here d by dx of, so sin x by 1 plus cos x. Sin x by 1 plus cos x. See, observe here, this is considered as u and this is v, now which is in the form of u by v. So now, so dy by dx is equal to, so v into, that means v means 1 plus cos x, this is denominator into, so derivative of numerator, that is d by dx of u, that is sin x, so sin x minus, so again u into, that is sin x into, so derivative of denominator, so that is 1 plus cos x, whole divided by v square, that is 1 plus cos x whole square. So now this implies, so dy by dx is equal to, here 1 plus cos x into, so derivative of sin x, that means d by dx of sin x. So d by dx of sin x is standard form, we know that cos x, d by dx of sin x is cos x, so that's why here into cos x and minus, so here sin x into minus sin x into derivative of 1 plus cos x. See, derivative of 1 plus cos x means d by dx of 1, we know that derivative of a constant is 0. So that's why here derivative of 1 is 0 and here place derivative of cos x, that means d by dx of cos x. So the standard form of derivative of cos x is, we know that, so minus sin x. So this is the formula, right? So d by dx of 1 plus cos x, 1 derivative is 0, cos x derivative is minus sin x. Whole divided by, so here 1 plus cos x whole square. Now what we get here, so dy by dx is equal to, if you multiply, this is with cos x, so now cos x into 1, that is cos x, and plus cos x into cos x, we get cos square x, and here minus sin x minus sin x into, here also plus into minus is minus sin x whole divided by 1 plus cos x whole square. 1 plus cos x whole square. So which is equal to, we get here cos x plus, so here cos square x, so cos square x and minus into minus is here plus, so sin square x plus sin square x whole divided by here 1 plus cos x whole square. 1 plus cos x whole square. See, observe here, so dy by dx is equal to here cos x and here plus, so cos square x plus sin square x. So cos square x plus sin square x, we know that cos square theta plus sin square theta is equal to 1. We have the identity. Like that, in terms of cos square x plus sin square x is also 1 whole divided by here 1 plus cos x whole square. Now observe here, so 1 plus cos x in the numerator and denominator gets cancelled. So we get here, finally this implies, so dy by dx is equal to, in the numerator 1 by, in the denominator we have 1 plus cos x. So finally what we get, the derivative of given y is equal to, so that is dy by dx is equal to 1 by 1 plus cos x. Like this we can prove. In this video we are going to discuss, if x is equal to a cos cube t, y is equal to a sin cube t, find dy by dx. So now here two functions are given in the solution, given that x is equal to a cos cube t. So here it is a function in terms of t in the right hand side. So now differentiating with respect to t on both sides. Now we get d by dt of x is equal to, here a is constant with respect to t, so now d by dt of, so this is cos cube t. So now dx by dt is equal to, it can be written as a into d by dt of cos t whole cube. Now in the right hand side, which is in the form of d by dx of like x power n. Here what is x in cos t is x, n is 3. So now here n into, the standard form is n into x power n minus 1. Same like that we can differentiate it. So dx by dt is equal to, so a into, so here n is 3 into x is cos t, so cos t whole to the power of, so n minus 1, that is 3 minus 1. Again we have to do the derivative of, so cos t, with respect to t. So now we get, so dx by dt is equal to, so this is a into 3, that is 3a. Here cos t whole to the power of 3 minus 1, we can write cos square t into derivative of cos t. So we know that cos x derivative is minus sin x. Same like that, cos t derivative is minus sin t here. Finally we get dx by dt is equal to minus 3a into cos square t into sin t. So this is dx by dt. Now again the function y is also given here. The function y is given here. So now y is equal to a sine cube t. A sine cube t. Now this is also differentiating with respect to t on both sides. With respect to t on both sides. So now d by dt of y is equal to a is constant with respect to t. So a into d by dt of this is sine cube t. So now which is also can be written as dy by dt is equal to a into, so d by dt of, so this is sine t whole cube. D by dt of sine t whole cube. So which is also same like this formula d by dx of x power n. So which is equal to a into, n is 3 here, x is sine t, so that's why here sine t whole to the power of n minus 1, that is 3 minus 1 into again derivative of sine t, again derivative of sine t. So now here, so dy by dt is equal to 3a into sine t whole to the power of 3 minus 1, that is sine square t, into derivative of sine t, so that is we know that cos t. See here, we know that the standard form here also I applied. So derivative of cos t, that means using the formula derivative of dy dx of cos x, which is equal to minus sin x, and similarly, so derivative of sin x, we know the formula sin x is equal to cos x. Sin x is equal to cos x. So I applied here sin t is cos t. So finally what we get, dy by dt is equal to 3a into sine square t into cos t we get. See, actually what we have to find with the given functions, we have to find, both are in terms of t functions, we have to find dy by dx. So therefore here this is 1 and this is condition 2. To get the dy by dx, here therefore 2 by 1. So dividing the condition 2, that is dy by dt, by condition 1, so with dy by dx, which implies, so dy by dt by dx by dt is equal to, see dy by dt what we have, 3a sin square t into cos t, 3a sin square t into cos t, whole divided by, so dx by dt is we have minus 3a cos square t into sin t, cos square t into sin t. So now here 3 gets cancelled and a also gets cancelled, and 1 sin t is also gets cancelled in the numerator and denominator, cos t is also gets cancelled in the numerator and denominator. Now here dt is also gets cancelled. Finally we get, so dy by dx is equal to, which is left over in the numerator, that is sin t by, in the denominator which is left over, minus cos t. So which is equal to, so sin t by minus cos t, we know that tan t. So therefore finally, so dy by dx is equal to minus tan t. So like this we can find with the given functions dy by dx. In this video we are going to discuss, if y is equal to cos h2x, find dy by dx, which is also PYQ question. So now how to find the dy by dx here. So given that y is equal to log of cos h to x. So now differentiating with respect to x. Differentiating with respect to x on both sides. Now we get d by dx of y is equal to d by dx of log of cos h 2x. Cos h 2x. See, observe here carefully, which is in the form of like log x. So in place of x, what we have? Cos h 2x. So now here, first we have to do the derivative of, which is in the form of log x, no? So we know the derivative of log x. So d by dx of log x is equal to 1 by x. We know that. So that's why here, which becomes dy by dx is equal to, so log x derivative is 1 by x. Here x is nothing but cos h2x. So that's why 1 by cos h2x. Again we have to do the derivative of d by dx of cos h2x. Cos h2x. So observe here carefully, this implies dy by dx is equal to 1 by cos h2x. 1 by cos h2x. So now here derivative of cos h2x. So derivative of cos h2x is like it is cos hx. In place of cos hx, in place of cos hx, in place of x, here we have 2x. So that's why here, so d by dx of cos hx, d by dx of cos hx is equal to, we have sin hx. So same like that, here we have to do the derivative of cos h2x, so which is also sin h2x. Why? Because in place of x we have 2x, again we have to do the derivative of 2x also. We have to do the derivative of 2x also. So now, which implies dy by dx is equal to, dy by dx is equal to, we get here sin h2x, sin h2x by cos h2x, cos h2x into derivative of 2x. Derivative of 2x is 2 into d by dx of x. So that's why we get here, so d by dx of 2x is 2. So now here clearly dy by dx is equal to, therefore dy by dx is equal to, dy by dx is equal to, we know that sin h, so sin h2x by cos h2x, sin h2x by cos h2x, we can write tan h2x, tan h2x into 2. Finally we can write, so dy by dx is equal to, so 2 tan h2x. So like this we can prove from the given function dy by dx.